Okay, let's talk about 3.1, the measure of centers. Now, with this, guys, do remember that the measuring of centers, you are going to learn about mean, median, and mode. These should not be new words for you guys. Hopefully, you've heard them before. And when is it appropriate to use which one of these measures of centers? So our first one is going to be a sample mean. This is basically what we refer to as an arithmetic mean. Um, this is the one when you hear the people say the word average, this is the number one idea that they're actually talking about, okay? So arithmetic mean, basically what that means is you're going to add up all the data, divide it by the number of data items, okay? And we have a formula, but it's kind of like most people know this not necessarily by the way the formula is written. The official formula has this summation symbol, and basically this symbol here just means to sum it all up. Okay, and you're going to sum up everything that's like basically listed right after it. Okay, the little I is referring to all the different individual data points. Okay, and that's why in the first one up here you see x sub 1 plus x sub 2 plus dot 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 x sub n. And again, n and the 2 and the 1, these little things down here are making only reference to like where they are in the data. Okay, what you really want to kind of make note of is this thing right here, which is our x bar. X bar is associated with sample mean, so really important to keep that in mind. So x bar is our sample mean. Now we have a population mean. The formula looks absolutely identical because it basically is the exact same formula. The only difference is that we're dealing with a population. Okay, and again, what you really need to pay attention to is that symbol. That symbol is mu, and mu is when we refer to the population. So let's give this a shot. So students were surveyed to find out the number of hours they sleep per night during a semester. Here, a sample of their self-reported responses. Calculate the mean. So it's asking me to calculate the mean, but somewhere in the problem, I read the word sample, correct? So this is basically what we're referring to as a sample mean. And with our sample mean, remind ourselves that we're basically going to sum up all of our data values and divide by the total number of data values. And because I am using the word sample, we're going to use the notation of x bar. Again, even though x bar and mu have the exact same, they literally mean the exact same formula, and they're found the same way, what you really kind of want to pay attention to is the symbols that you're writing down, because in this case here, in the problem, it said the word sample, so we want to kind of stick with our sample notation. And it will come later, you'll learn kind of why we want to go x bar or mu, okay? So we've got our base formula. I'm going to basically take all of those individual hours that the students' responses were. So 5 plus 6 plus 8 plus 10 plus 4 plus 6 plus 9 and divide by 7 because there's 7 items. And 48 divided by 7, which is going to give me approximately 6.857143. And again, guys, do know that you notice I switched from a really nice clean equal sign to this one here, which is a squiggly equal sign. My squiggly equal sign just basically means that there is a rounding that's going to end up happening. Normally, if your calculator spits back out about 6 to 8 decimals, the calculator automatically rounds. So if it has basically anywhere from like 1 decimal to about 5 decimals, then that means the calculator has cut it off and it's not a rounded number. But from like anytime it has like 6 to 8 after it, normally that means that the calculator has predetermined to round. And I say 6 to 8 because it's also going to depend on like how many numbers are in front of it to just say whether or not the calculator's pre-rounding. So rounding that to 1 decimal place is going to give us 6.9. So our sample mean for the number of hours that students reported sleeping during the night per night for a semester is about 6.9 hours. And again, this is my sample mean. Now, there is an alternative method, and that alternative method is basically using the calculator. And I'm going to kind of walk you through those steps for the calculator. So you're going to find that sample mean using a TI 83 or 84 calculator. The first thing you want to do is you actually want to hit the button for stat and then choose edit. So stat and then edit. And when you're doing this stat, the button is actually says the word stat here, and then edit, you can either hit the number 1, okay, or when you hit stat, you can make sure 1 is highlighted and hit enter. Either way, that's going to work. And then now you're going to enter in your data into the list. Now, as you guys can see in my actual calculator here, I have stuff that's already in here. It's not exactly the same stuff. So what I'm going to do is I'm going to go up here, hit clear, and enter. Always hit clear. You never want to hit DEL, which is delete, clear only. So as I am putting in my items, I'm going to literally type 5 and then hit enter. Okay, and it's kind of like an Excel file, so you literally are just adding in your items as you go, and hit enter will take you to the next cell down. So 6, enter, and again, notice again I am moving down in a vertical manner. Okay. Now you'll notice that as I was entering those in, I did make a mistake. That should be 10 and not 104. So all I have to do is go back up here and I can retype in the actual number and hit enter, and it fixes it. So if you do happen to have anything that in there that you kind of mess up on, go back up and kind of just put it back in there and retype in and hit enter to execute. And then again, it'll move down to that next thing and you can just double check again. Okay, I do highly recommend anytime that you are entering in data like this, double check to make sure everything looks appropriate. That is where majority of the students make their mistakes, is they happen to kind of forget what they need to do. Okay, so now that we've got all of that in the calculator, the next thing we're going to do is you've got it all in, we're going to hit stat again, and then you're going to choose calculate, and then we're going to go to 1 var stat. Now, please hit enter twice. Now note, if it's not showing list 1, or if you are missing list 1. So make sure that when you have done the initial entering of your items, be sure you know where did you actually locate that items, okay? So to help you guys out, again, following along here, I notice I have list 1 here, which is why I said don't ever delete it, because it defaults to list 1, so that's why. And so I'm going to hit stat, arrow over to calculate, and number 1, again, you can hit 1, or you can have 1 highlighted and hit enter. Okay. For those of y'all that are on my TI-84s, you should see this beautiful screen here that says list 1. If you have anything listed in frequency list, go ahead and delete it out, because we did put everything in one list. And then just arrow down and calculate. For those of you guys who are in my TI-83s, okay, my TI-83s will not see that pop-up menu. You're going to see something that looks a lot like this, where it just says 1 var stat. You're going to need to want to add in the list 1, kind of get in the habit of putting it in there. Are you using 1 list or 2? We'll look at the 2 list in a little bit later in this video, but if you have 1 list, you want to go ahead, because it's not going to show up for my 83 students. Yours is going to show up like this. All you have to do is hit second and number 1. Notice right above that, it does say L1. Okay, so now that you've got that in there, you just hit enter and you'll get the exact same screen that shows up for what everybody else has. What you want to notice is basically that very top part there. Okay, so in that very top part, that first value is called X bar, and guys, didn't we just remind ourselves that X bar is that sample mean? There are a bunch of other items there. These are just kind of other descriptive statistics that we will learn a little bit more about as we work our way through these different chapters. But currently right now, we're not going to be too concerned about it. I do want to point out that you do see the number N, letter N here. And remember that we said that we did have 7 data values, and so that's a great way to see exactly how many data values you actually had. But again, we are kind of paying closer attention to that first part up there where it does say that X bar. That is kind of my big go-to one that I really want to see there. Okay, and that's kind of the basic idea of the calculator. Now we will learn it a little bit later with some more, but do keep it in mind that this is kind of your go-to to go back to, and 1 var stat is a very important menu. Okay, so our next example is Rutherford downloaded 5 new songs from the internet. He knows that on average, or also known as the mean, the songs cost about $1.23. Now, if 4 of the songs cost $1.29 each, what will be the price of the 5th song that he's downloaded? So the first thing I want to kind of make note of is that we are looking for what is the price of one of these songs. I already know the average, okay? So we are already given the mean. So what we can do is we can use that formula for the mean and tweak it a bit with that missing value. This is where using a little bit of algebra is going to help out. I can't really use my calculator to help me, but I can use some just early beginning algebra solving equations to help us out. Okay, so my formula here is I've got x sub 1 plus x sub 2 plus x sub 3 plus x sub 4 plus x sub 5. 5 because we have 5 songs divided by n. You'll notice I am using mean here. Nowhere in the problem was it talking about a sample. It was saying that the kid was going to download 5 songs and they told you all of it for his 5 songs. This is for him, so we're going to use mu there. And in the formula, remember the average, that mu was $1.23. For the first 4 songs, he paid $1.29 for. That last one, this is the one that I do not actually know. And since I do not know that one, that's what I'm looking for. And we know there's 5 total. So I'm going to sum up all of these right here, add them all together, simplify those out. And then once I've summed them up, it's still all being divided by 5 plus that x sub 5 here. So I need to basically get rid of that divided by 5, and the opposite of division is multiplication. So I'm going to multiply both sides of my equation by 5, because what you do to one side equal sign, you do the same thing to the other if you were trying to solve. Over here, when I combine like terms, I did not need to move anything across an equal sign, so I didn't have to worry about doing something to both sides. Okay, so you should get $6.15 equals $5.16 plus x, our unknown. I'm going to subtract $5.16 from both sides, so that way, in this case here, we happen to get this to cancel, leaving me with x by itself, and we get 99 cents equals x to the 5th. Now, guys, I understand that you could easily have done this entire problem with maybe a guess and check, because literally you'd be doing the exact same thing here. But what we're doing now is we're kind of doing that guess and check, but in a little bit more of an algebraic standardized form, because this will work every single time, and we can use this basic idea to find items later when a guess and check is not as easy. Okay, so if you can, try to start to use that algebra now. So the cost of that 5th song needs to be 99 cents for Rutherford, if the average of all the songs when downloading is going to be $1.23. Now, the other one is our weighted mean. Now, a weighted mean, this should sound a little bit familiar for you guys, because most courses in college actually use a weighted average to do their grades. Now, that's not all, but a good majority, and especially in a lot of my courses, I like to use weighted averages. This basically means that each data value does not hold the same importance. So tests are a little bit more important than homework, whereas the final exam is also a little bit more important than a homework. Those types of things that you would see. So in this one here, the formula is going to look very much the same. The only difference is that now we have to take those data values and multiply them by their individual weights. So let's look at an example. The syllabus in Walter's U.S. History class states that the final grade is determined by tests, which are 40%, homework, which are 20%, quizzes, which are 10%, and the final exam, which is 30%. Now, 2 students in the class, Walter and Virginia, want to calculate their final grades. Now, below are their average grades in each category for test, homework, and quizzes. And they also individually guessed at what they might have scored on the final exam. Okay, so again, the categories of test, homework, and quizzes are their averages for that category. So let's look at Walter. Walter is going to have a test average of 83, homework average of a 98, and his quiz average is a 90, and he's going to guess that he made an 87 on the final. And for Virginia, We're going to actually do hers a little bit differently. We're going to do that one with the calculator. So I'm going to do Walter's with a by hand method and Virginia's with the calculator. With Virginia, she's going to have a test grade of 95 average, a homework average of 45, quiz average of 66, and then her final exam, she guessed she made a 90 on. Okay, so the first thing you want to do is make sure that when you're recognizing what are the data values and what are the weights. So we have those categories of test, homework, quizzes, and final exams, and we were given those grades for those. The data values, these are the data values. Okay, those grades that we were talking about, those are the data values. This is what we're going to plug in for X in our formula. The weights, these are those weights. Okay, and we're going to use those as our W's. Now, do understand you cannot plug in 40% into the formula. You do need to change all of these percentages into decimals. Okay, so we're going to take each individual data item, multiply by its weight, and then we're going to divide everything by the total sums of the weights. So here we have our 83 test average times a 40%. And again, changing that to 0.4 because that's what it's got to be as a decimal. We have a 98 homework average times 20% of the grade, plus 90 for our quiz average, which was 10% of the grade, and its guess of an 87 on that final, which is 30% of the grade. Now, each one of these guys, remember, you're adding them all up, dividing by the total of the weights. Now, all of the weights, again, need to be in that decimal form. I cannot stress that enough. It's really important to get that. So in our case here, when I add up multiplying our averages times our weights and then adding those all up, I get 87.9 divided by 1. It should be divided by 1 because all of these made up 100% of the grade. So Walter is going to have a final class grade to be 87.9 if he guessed correctly of what his final grade was. Now, as noted when calculating Walter's grade, the weights and percentages for those category were the same. However, the values of X for Virginia's are different, but the category percentages for those weights were the same. So as like we said earlier, we are going to use the calculators to help us out here. And the following steps are going to be very similar to what we did for calculating the sample mean. But in this case, we are going to need to do not just one, but two lists. So again, remind yourself the first thing you're going to need to do is hit Stat and then Edit. And then you're actually going to have to put all of those value items into the list. Okay. So now looking at Virginia's grades, we are going to input them into the calculator. Again, this time we're going to need two lists. So again, I'm just going to start by hitting Stat and Edit. There we have it. Again, I do have stuff already in there. So again, I'm just going to go up and highlight and hit Clear, Enter, because I want to clear the list so I can start fresh. And I'm going to enter in Virginia's grades, again, moving vertically down. So all of my data values from one set, all sets should be a vertical set. Okay, I am going to move over to the second list because the second list, I need those category weights in there. Okay, and on these ones, do remind yourself that when you are typing them in, to type them in using a decimal, don't type them in with just the number itself. So you need to, instead of put 40%, you are going to need to put in 0.4. Instead of 20%, you're going to need to put in 0.2 and so on. I do recommend that as you guys are looking at these, a couple of notes is to make sure that they line up perfectly. So the little dot, 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 and dot, dot, dot at the bottom, if these are mismatched, when we run our one-var stat, it's not going to work. It's going to say that we have an error message. Okay, the second thing I want to do is I want to make sure that my category weights and my grades all match up. So we know that we were in test, homework, quizzes, and final exam, right? And our weights were 40%, 20%, 10%, and then 30%. So again, make sure that these all match up in the right categories. You cannot mix and match. That will not give you the right answer. So now that you've got all that stuff in there, and again, we put it in two lists, we are going to go back and do that one var stat. So again, press Stat again, move over to Calculate. You're going to select the one var stat. Now at this point here, This is where we have to tell it's going to be 2 lists and not just 1. And again, depending on whose calculator you're looking at, are you looking at a TI-83 or are you looking at a TI-84? They're going to be a little bit different. So understand that for my TI-83s, you are going to have to put in list 1, comma, list 2. And for my TI-84s, you're going to have that menu screen pop up. Okay, so looking at what we had here, again, I'm just going to hit Stat, move over to Calculate, hit Edit. For my T84s, you don't need to worry about this second 1, comma, second 2, because this is already listed in here with the different separated items. So you will need to put in list 2, and we're going to put that in the frequency list because the frequency list is the second one. So if you have 2 lists, you want to make sure you have list 1 and then list 2 for the second one. And then again, just arrow down and hit enter. And again, how I put that list 2 in there was second 2 button. And then calculate. For those of y'all that are my TI-83ers, when you plug in that 1var stat, you choose it, you hit enter, it's going to show you 1var stat. You are going to have to say list 1, comma, list 2, and you have to put them in there. If you do not put list 1, comma, list 2 for my TI-83s, you will get it wrong. Okay, and it won't do the math correctly for us, and you'll hit enter and you should get this nice, lovely, beautiful screen. Okay, again, looking at that side by side there so you can see everything. We can see that X bar was our 80.6. Again, there is some other stuff. There's even a little down arrow. We'll get to those in another video, what those all are, but we will be learning so much about all of this at a later date. Okay. So let's try another example. At the end of the semester, Heather knows all of her grades in her sculpting class except for her final exam. Now, here's the breakdown of the points of her categories, how much each category is worth, and what her grade is at those, okay? And how much they count towards that final category grade is in parentheses. So we have tests, which are 35% of the grade, and she's averaged to 78. Our class assignments are 20% of our overall grade, which she has averaged to 92 on. Her semester project is 35% of the grade, which is 93. And then we have our final exam, which is 10% of the grade. However, I do not actually know the final exam grade yet. We're not there yet. We haven't taken it. So what we want to do is we want to actually start off with our first question here, is we want to calculate the weighted mean for the portion of the grade she has completed, meaning we want to know what her grade is as of this moment. Okay. The second thing we're going to do is, okay, well, what does she need to make on the final to get that desired grade of an A? And we're going to say a 90% A because a 90 is the base level for an A in her class. Now, we are going to assume that the final exam is only worth 100 points. Now, the last thing I want to know is I want to know her grade for what she would need to make to get an 80% average, so a B in the course. And again, assuming that 100 is the highest I can get. So our very first part there, the first question was asking very much similar to one of our previous examples, just for getting our weighted average. So we just need to know our weights as a percentage for each category times the data value, and that will tell us what she has so far. Now, do remember one of the things that I do have here is that I don't actually know all of the grade components. So the one thing I didn't know was the final exam, but since I don't know the final exam, I'm not going to add it in because I don't know what that grade is. And I'm not going to add it in the top or the bottom. I want to only have what's possible currently. Okay. And as you do this, when you start adding them all in, so you take each item times its weight, you'll notice that our average here is about an 86.9. But again, what I'm dividing by here, this is not 100% of the grade. It's only a small portion of it. Because we're missing that last 10% that came from the final. Okay, so currently Heather's grade in this course is an 86.9 for her sculpting grade, and this is without the final exam. So our second question that we asked along with this was, well, okay, now I want to know what does she need to make on that final, which is the rest of that 10% of the grade, so that she can actually have an A in this course. Now an A is going to be 90, and that's going to be her ending average, correct? So again, using that kind of weighted average idea again, I'm literally going to have almost everything look exactly the same, but this time I am adding in the parts that I don't know. So you'll notice I've added in an unknown variable, x, and again, choose whatever letter you want. It doesn't really matter. X is my default, times the weight of what it would be. You'll also know I've added it in down here as well, even though I don't know what the actual grade is. I've also put in 90 over here. So this is where I actually know what that average is going to end up equaling. So I am solving for the unknown. So as you guys are solving for the unknown, this is where that little bit of algebra is going to come in. So I'm going to say 90 equals, and I need to sum up all the stuff on the top and sum up all the stuff on the bottom I can. So I'm going to get 90 equals 78.25 plus 0.1x divided by 1. Again, since I'm dividing by 1, I'm just going to let that 1 kind of divide out, and it's going to look like it disappears. I'm going to solve for my x, so I need to isolate that term. And to isolate, that does mean I need to take this 78.25 to the other side by subtracting it, which is going to leave me with 11.75, which equals our 0.1x. I am going to divide by that 0.1, and I get x equals 117.5. Now, again, remember, x is literally the grade she needs to make on her final to get an A in this course. Now, one thing we remembered is I told you the highest grade on the final was 100. So basically, since x is bigger than 100, it appears that mathematically impossible for Heather to actually get an A in this course. Now, her highest final grade that Heather can actually achieve is 88.25. That would be basically meaning she gets 100% on that final. I'll let you do the math to verify it on your own, but you kind of know like that's as high as she can go. So she can't get an A. So since we know it's impossible to get an A, what we want to do is we actually want to do that third question, part C, and we want to see, well, what does she need to make to get a B in the course? And again, remember, we're looking at what's to get that 90 or 80 or 70. When you change those out, this is the lowest grade you need to make that exact 80%. Okay, so we'll still let x be our unknown, and we'll have the formula. It'll look very much the same as what we just did a moment ago. Instead of it being 90, I'm going to replace it with 80. Okay, same steps. I am going to solve it all out, so it should look very similar. So I get 80 equals 78.25 plus 0.1x. I'm going to subtract over my 78.25, which is going to give me a 1.75. This one's a little bit different because remember it's 80 minus the 78.25. I am going to divide by that 0.1, and we get x equals 17.5. So even though our A is impossible, Heather basically only needs to score 17.5 or higher on the final exam in order to secure a B in this course. And I hope this helps you guys as you calculate your grades for some of your college classes. And keep this in mind, okay? So let's talk about median. So all of that was just for the mean. Now, median and mode are the other two we need to talk about. For median, think about the words, it's in the middle. Median is middle, okay? So the first thing you need to do in order to find a median is you need to put the data in order from either smallest to largest or largest to smallest. So smallest to largest is what we call ascending order, and largest to smallest is going to be descending order. Okay, once you've done that, you're going to either have 2 or 3. So understand that this is this or this option. And this is where you basically have to count. So if it contains an odd number of values, okay, whatever's directly in the middle is going to be the value. If you have an even amount of values, okay, evenly, it's going to split, and you're going to basically have to take those 2 middle values, add them together, and divide by 2. So let's take a peek here. So given the numbers of the absences for samples of students in 2 different classes, we're going to find the median for each class. So where does the middle range fall? The first thing I notice is that in this first one, 3, 4, 6, 7, 8, 2, 8, 9, it's not in numerical order. Same thing with part B here. It's 5, 7, 8, 1, 4, 9, 8, 9. I've got to put these in order before I do anything. Okay, so with that first one, once you put it in order, I did notice that I did have 7 values. So again, with those 7 values, you're going to have 3 on one side, 3 on the other, and smack dab in the middle is going to be that number 6. Again, has to be put in order first before you start this, and then basically you're just kind of counting an even amount. So if anything, for those of y'all that are doing this by hand and you need a little bit extra help, kind of just mark off until you reach that middle. And if you have that one item, that's going to be it. And if you mark it off and you end up with 2 items in the middle, that means there should be an even amount of data, which then you're going to have to average. Okay. So again, first thing you want to do, put them in that lovely order. Once you put them in that order, you're going to add them together and divide by 2 once you find those middle ones. These are evens amounts. So again, and notice I'm taking one in the front and one in the back as I do this. And as I do this here, I notice like if I do this, I'm going to run out. So these 2 are in the middle, add them together, divide by 2. So the median for this sample is going to be 7.5. Now, there is an alternative method. That alternative method is with your calculator. Okay, so the median is one of the most descriptive statistics used in the TI 83 or 84 plus. The calculator will actually give that to you. So remember when we were looking at that 1var stat option, when you do that, so stat, arrow over to the calculate menu, and then select 1var stat, put everything in list 1 before you do that. Okay, so make sure that you've edited list 1, and then you're going to run that 1var stat again. Okay, so again, these are all those lovely steps, guys. Remember to go back through. And then once you run it, at this point, you're not going to see it. Okay, so this is where X bars is at the top. You do actually want to make sure to arrow down. And when you arrow down, it will say MED. And MED is your median. Okay, mode is the last type of measuring of center that we need to talk about. Mode is the value in the data set that occurs the most often. So mode for most, median for middle, mean is average. Okay. For data values that only occur once or an equal amount of times, that means there's no mode possible. If one value occurs most often, this is going to be that one item, and that's going to be called a unimodal. Okay. If you say have 2 values that show up the most often, but they show up the exact same amount, so that would be bimodal. And sometimes if you have more than 2 values that show up more often, these are normally more for larger sets, that would be multimodal. Again, but do remember that if they all show up the same amount equally, then that is not going to be any mode at all. So given the number of phone calls received each hour during business hours for the 4 different companies here, we're going to find the mode of each. So our first one there, we have 64617872554. I would say it's probably really helpful if you'll start by actually listing this in numerical order. Do you have to put it in numerical order? No, but sometimes it is helpful when you put it in that numerical order. And when you do that, it does give us this really nice item to where we can see that we wrote 7 more often than anything else. So 7 is the mode. And this data set is basically a unimodal data set because there's only one mode. Okay, so looking at B here, we have 3, 4, 7, 8, 1, 6, 9. Again, try to put them in order. Any of these, especially some of these B and C's, you'll notice they're not in order. D is already in order. It's 2, 2, 3, 3, 4, 4, 5, 5. If it's already in order, it makes it a little bit easier. If it's not, it is sometimes helpful to make that rearranging to allow us to be able to quickly see them. Okay, so with B, once you've sorted it out, it's going to give you 1, 3, 4, 6, 7, and 8, and then 9. I do notice that none of those values repeated. So in this case here, there's not going to be a mode. They're all repeated the same amount of times. They only ever show up once. So this is basically what we would say neither. It's got no mode whatsoever. So it's not unimodal, it's not bimodal, it's not multimodal, it's neither. Okay, our C that we were looking at, again, really is going to be super helpful if you do put them in order. So 2, 2, 3, 5, 7, 7, 8, 9. I notice 2, 2, 7, 7. Both of those occur more often than our 3, 5, 8, 9. And they both show up the same amount of times, so they both show up twice. So both of them are the modes. So this would be a case in which it's bimodal. Now our last example, notice that it was already set up for us in that nice, beautiful order. Okay, and one of the things that was when we were looking at this one here, remind yourself that it was basically 2, 2, 3, 3, 4, 4, 5, 5. They're all showing up the exact same amount of times, right? So I don't really need to worry about sorting it because it was already in order, but everything shows up twice. So if they all show up the same amount of times, one doesn't kind of show up more than the other. This is no mode. There's not a mode here. It's neither unimodal, it's not bimodal, it's just no mode whatsoever. Okay. Now, I do have a little bit of word of warning here, is that although a lot of statistical software packages may identify the mode of data, so like you could have something like Excel or something like that, then yes, some of those things actually allow to look at data and tell you what has the mode there. However, the TI-83 or 84 Plus does not do that, especially in our one var stat. It's not one of those that's listed, okay? So these you are going to kind of want to do by hand. Okay, so let's actually take the following example and let's find our mean, median, and mode for them. So given the recent economy and changes of attitude in society, many people choose to take on another job after retiring from one. Below is a sample of ages at which people truly retire. That is, they stop working for pay. And we're going to calculate that mean, median, mode. So we have 84, 80, 82, 77, 78, 80, 79, and 42. Okay, guys, take a second, pause it, and try to see if you can do it on your own. And give it a second and come back and we'll go through the answers. Okay, so now that you've had time, remind yourself that for your mean, remember to just sum up all your data points, divide by the total number of points. In our case here, when you add them all up, you should have ended up with 75.3. Again, do remember you do have the option to use the calculator to help you with this. Median, we will need to have put these in number order from smallest to largest. Okay, so, and then I did notice that we had 8 data points. So when I put them in order from smallest to largest and there's an even amount, that means I am going to take the 2 middle ones, which is 79 and 80. I'm going to add those together and divide by 2, and we get 79.5 is my median. Again, the calculator will help you out with the median if you need to. Mode, the calculator will not help you out. Okay, so for this one here, we are going to have 80 happens to occur more than any other one, so that is the mode. Now, I went ahead and put out a dot plot for all of those items that we just looked at, and as you can see in the figure, the measure of the 3 centers here, the mean is closest to our outlier, and meaning basically, if you'll notice, 42 is a little bit away from the rest of the data. Most of the data is kind of in a central localized area here, so you'll see like all of those dots kind of fall in that area. But when you look at your median and your mode, they are not actually affected by any outliers, and that's really helpful in seeing something, whether or not you need to pull an outlier out of your data and throw it away. So let's determine the most appropriate measure of center. If you are looking at qualitative data, please remember that the mode should be used. Qualitative data, those are the stuff with words. Okay. For quantitative data, it's going to depend on whether the data has outliers or not. So quantitative data, the mean should be used if the set contains no outliers. Okay. If your set contains outliers, then you should probably use the median. Okay, so for any type of number data, we lean towards the mean unless it is got outliers or skewed data. Okay, an outlier itself does not necessarily mean that the data isn't already skewed, so keep that in mind. So let's look at the following. So we've got t-shirts of American women, salaries for a professional team of baseball players. We have the prices of homes in a subdivision of similar homes. And then we have professor rankings from students' evaluations of the scale best, average, or worst. So for the t-shirts, that is stuff like small, medium, large. Those are words we're using to describe. So for that one, the best measure of a center will be the mode. For our baseball players, baseball salaries is money. So that's money and that's a number. So quantitative data, with baseball players, you might have somebody that's a superstar on the team, which might make a heck of a lot more than the typical player. So in that case there, you maybe have an outlier. So I would choose the median for that one. Home prices, again, prices, money, you're dealing with numerical data, quantitative data. There are no outliers in this one because we put in the caveat of since homes are similar, so therefore I would just use a mean. Again, please make sure you're reading the problem very closely because again, if I hadn't said that the homes were of similar value, then I probably would have went with the median, like with the superstars. Okay. The last one, we talked about the ranking of professors. Again, best, worst, those are words. So for that, you want to use your mode as your center. Graphs and measures of your mode. So guys, we just talked about it. If you were to look at it in a nice graphical way, mode is going to be at the highest part of it. Your median should meet about halfway, and then your mean is if you have any outliers or the data is skewed, it's going to be closer to that skewed area. So in our case here, let's determine which letter represents the mean, which one's the mode, and which one is the median. Again, wherever the highest point is, so here's my highest point, that is going to be the mode. That is the thing that shows up the most, so highest point, right? And I do notice that I have this kind of pull to my data here. So this part right here, C, that is going to be my median. Sorry, excuse me, that's going to be my mean. Because my data is being pulled. And C doesn't really look like it's the halfway point, does it? So if I look at it closely, that is my mean. But here, in the middle here, B, that is my median. And again, median for that middle. Mean is going to be the average of all the stuff. So you've got some really high things here, and you've got some really low things. So that's why that mean is kind of pulled the direction of where the items are. Take a second to look at some of the properties of the mean, median, and mode here. And here's a nice, lovely chart. Again, remember with mean, we think about the word average. For median, you're going to have that middle value. And mode is which one shows up the most often. Understand that for your mode, it's going to have to be a data value. It has to appear in your original set. For the mean and the median, it may or may not be. Okay, because there is a little bit of math involved on some of those, so it may not necessarily be the exact number showing up in your data set. In your mean and your median, it can only be one item as an answer. For the mode, remember you can have more than one mode, so you might actually have multiple answers here. Again, for your mean, an outlier will affect it. For the median, it will not affect it. And for your mode, it's not affected by any outliers because it's just whatever shows up the most. For the mean, again, you want to make sure to use this for number data with no outliers. Okay, so if there's no indication of an outlier, we're going to use what we say is the mean is going to be the best way to measure the center. If it has an outlier, you want to use the median as the best measure of center, and anything that is qualitative data, meaning that wordy data, then that's where you want to use your mode.